Explain with examples coupling, cohesion, throughput, and latency. Coupling. Coupling refers to the degree of direct interdependence between modules. Tightly coupled systems have many dependencies, while loosely coupled systems have few dependencies. Example: tightly coupled. Imagine two classes in a software application where class A direct calls methods in class B and relies on its internal data structures. If class B changes, class A will likely need changes too. For instance, an e-commerce platform where the payment processing class directly interacts with the inventory management class, loosely coupled. Instead, if a class A and class B interact through a well-defined interface or service, they are loosely coupled. Changes in class base implementation won't affect class A as long as the interface remains the same. For example, in a microservices architecture, the payment service interacts with the inventory service through a REST API. Cohesion. Cohesion refers to how closely related and focused the responsibilities of a single module are. High cohesion means the module has a single well-defined purpose. Example: high cohesion, a class that handles all operations related to user authentication such as login, logout, and password management has high cohesion. All its methods are related to managing user session. Low cohesion, a class that handles user authentication, database operations, and UI rendering has low cohesion. These responsibilities are unrelated and should be separated into different classes. Throughput. Definition. Throughput is the amount of work done or data processed in a given period. It's often used to measure the performance of systems. Example: web server. A web server can handle 1,000 requests per second. This number represents its throughput. Higher throughput means the server can process more requests in the same time frame. Manufacturing. A factory assembly line that produces 200 cars per day has a throughput of 200 cars per day. Latency. Latency is the time taken to complete a task or the delay before a transfer of data begins following an instruction for its transfer. Network latency. Examples like network latency. When you send a request to a web server, the time it takes for the server to respond is the network latency. For example, if it takes 150 milliseconds for a packet of data to travel from your computer to a server and back, the latency is 150 milliseconds. Database latency, the time it takes for a database to return a result after a query is made. If a query takes 2 seconds to return the data, the latency is 2 seconds. Summary. Coupling. Degree of interdependence between modules. Lower is better for flexibility and maintenance. Cohesion. Degree to which elements within a module belong together. Higher is better for clarity and reusability. Throughput. Amount of work done in a given period. Higher is generally better. Latency, time delay to complete a task. Lower is generally better.